All right, so section 3, this is definitely the hardest one on the graphing because we put that B term, excuse me, in the middle there. So if we had, oops, I'm going to do that. And if we're going to do this one. So if you remember our steps, the first step is to do the axis of symmetry. And we do that using x equals negative b over 2a. So in this problem, I'd have x equals, the b is 4, but negative 4. So we have a negative in our formula, and then 2, and the a on this problem is just 1. So I get x equals negative 4 over 2, or x equals negative 2. So on the graph, on the x-axis, we go to negative 2, and I'm just going to draw this like little dotted line. There's our axis of symmetry. Our graph is going to be the same on the right side of that red and on the left. Okay. All right, then, excuse me. We plug in the axis of symmetry, plug in negative 2. So negative 2 squared is positive 4. 4 times negative 2 is negative 8 minus 3. So 4 minus 8 is negative 4 minus 3 is negative 7. So that 2, 3, 4, 5, 6, 7 is our vertex. So remember, we do negative 2 from the axis and negative 7 from plugging it in. Okay, so then we need to pick two numbers to plug in to figure out, and then we'll flip them over. Okay, and I typically just go like 2 to the right. It usually works best. So the first number would be negative 1, and then the next one would be 0. And 0 is always really nice because I'll show you something in a second. But I'm going to plug in negative 1. So we get negative 1 squared is positive 1. 4 times negative 1 is negative 4 minus 3. 1 minus 3 is negative 3. So we get, I plugged in negative 1 and got negative 6, which is right there. And then I get to flip it over to this side. Okay, and then I'm going to plug in 0, and I'm running out of space. I'm going to erase the minus 3 at the end. So y equals 0 squared plus 4 times 0 minus 3. And we get 0 plus 0, and we end up with that negative 3 at the end. So when I plugged in 0, I get negative 3. That will always happen. If you plug in 0, the answer is always the C number. No, 100% of the time. So if you can plug in 0, that's always a great option because it's super fast. It's just the number at the end. Okay, and there's our graph. So I did a problem a full problem at the beginning for a couple reasons. You won't have to do the full problem on all the problems today, okay? The first, let me see, are you doing odd or are we doing all of them? Let's see, we are doing odd. So the first two, it's going to, it asks find the vertex, find the axis of symmetry, and the y-intercept. And it's graphed for you. So you need to look at, like, the easiest thing to do is to find the vertex first, even though it's not listed in that order. It's the bottom or the top of the graph. So this blue point, like down here, that's the vertex. And so if you look down here, here's the vertex. The first thing it did say, though, is to find, it actually does say find the vertex, the axis of symmetry. So I would go in that order. Excuse me, sorry. Because this -2 for the x, that is the axis of symmetry every time. Whatever the x number is for the vertex, that is the axis of symmetry every single time. Because to find the vertex, you have to plug in the axis of symmetry. So, okay, but on the first two, you're just looking at a graph. Okay, what's the vertex? -2 is -7. What's the axis of symmetry? It's the x number of the vertex, but you need to put x equals. Don't just put -2. Put x equals -2. And what's the y-intercept? Where the graph crosses the y-axis. The y-intercept will be, when you're looking at the graph, it's just like, well, where does it cross? Okay, and so the y-intercept is 0, -3. Or you could just put -3. Y-intercept equals -3, like that's fine. I would take the coordinate or the y-intercept is -3. Okay, so first two, you're just looking at a graph, answer the questions. Should be pretty straightforward. The next set of problems, 7, 9, 11, find the axis of symmetry and the vertex. Doesn't say the graph. So your answer is x equal -2, -2, -7 for the vertex. Done. You don't have to draw anything on the graph. You're just going to do the red and the blue part. Okay, and then you'll get into graph the function. Okay, and it's going to say describe the domain and the range. Okay, so we're going to add that part to it. Okay, so let's do another problem. We'll do the whole problem. And we'll talk about the domain and range. Okay, let me find a good one. All right, well, let's... All right, so let's do 3x squared minus 6x plus 5. All right, so axis of symmetry, x equals, and this is a good one to look at. So remember, we're doing -b over 2a. So we have x equals negative from the -b part, and then also negative from the 6. And then 2 times 3. So that's +6, negative, positive, or we get x equals 1. So on a graph, we'll look on this one, x equals 1, so on the x-axis at 1, there's our axis of symmetry. Excuse me. All right, and then I need to plug it in for the vertex. 1 squared minus 6 and then a 1. So 1 squared is 1. 3 times 1 is 3, and then up here I can do negative 6 times 1 is -6. 3 minus 6 is negative 3. And I end up with positive 2. So our vertex is the axis of symmetry and what I got when I plugged it in. Okay, so 1, 2. Excuse me. All right, so and now I need to pick numbers to plug in. And I said I typically go 2 to the right, which would mean plug in 2 and plug in 3. You could go 2 to the left. There's nothing wrong with that. And the reason I say that is 0 is the first number to the left. And so remember, when we have 0, oh, I don't know why I wrote x. I should put 0 there. When we have 0, remember we just get 0 minus 0 is still just 0. We get 5. We get that number at the end of the equation. And then when I flip it over, it's as if I plugged in 2. So you see on the x-axis it goes 1, 2, and I have a point above the 2. Okay? So the next number I could plug in, I wouldn't want to plug in 2 because I'll get that same one. I could either plug in 3, or I could keep going to the left and plug in negative 1. It doesn't matter which one you do, you're going to actually get the same number because you're going to flip it over. Remember, we just flip it over to the other side. So I plug in positive numbers whenever I can. So we're going to get a big number on this one. So 3 to the second power is 9, which is 27, minus 18 is 9, plus 5 is 14. So when I plugged in 3, I got 14. So we could draw the numbers, but it's way up here. And then the other one is over here. Okay, so it should get really skinny. So remember when we talked about, excuse me, our pattern the last couple days, over 1, up 1, over 2, up 4. Well, this one went over 1, up 3, so it's going up a lot faster. Instead of just up 1, it went up 3, over 2, up 12. Instead of up 4, 4 times the 3 in the front is 12. Okay, so that changes a lot of things. So, okay, so for this problem, the domain, we talked about what's the domain and the range. Okay, listen carefully. On all these problems, the domain is all real numbers. Because I can plug in any number I want for x, I can square it, I can multiply it by another number, all real numbers. Okay, the range, however, is kind of where the graph stops going up and down. We talked about the range is the y part, up and down is y. So right here, that's the bottom of the graph. And if you notice, my blue line that I drew went through positive 2. So the range is y is greater than or equal to 2. It's where is the bottom or where is the top? If it was the top, then that means the graph is going down, and we'd have a less than. Okay? So let's do just a couple of just domain and range to make sure we understand. So let's say I had a graph that looked like this. Domain, all real numbers. The range, so again, there's the stops going up right at that point. That's like the top of it. And I went through 3, but it's going down. So less than or equal to 3. Okay. Excuse me. So there's just 2 of them that you're going to graph and then do the domain and the range. There'll be 3 of them that you do find the axis of symmetry and the vertex, which is kind of the 2 like main things to do anyway. Excuse me. And then like I said, 2 that you graph and do domain and range. Okay, the last 3 problems tell whether the function has a maximum or a minimum value. Then find the value. Okay, so maximum and minimum. Find the vertex. Okay, the vertex tells you everything. So you got to do step 1, find the axis of symmetry, plug it in to find the vertex. Okay, so like using this picture over here that we just kind of used for domain and range, the vertex is that dark, like black, like point. Okay, this is a maximum because the point is at the top. Okay, and the coordinate of the point, and like if you work the whole problem out, like it would be 2, 3 is the coordinate. Okay, so it says tell whether the function has a minimum or a maximum value, then find the value. The value is the y part of the vertex. So this one is a maximum and the value is 3. Okay, if I had so let's say my vertex was there. Okay, this is a minimum, and the vertex is 1, -3. So the minimum value is -3. Okay, so maximum is when the vertex is on the top, minimum is when the vertex is on the bottom. So how do you tell, and literally you don't have to graph these to know if it's a maximum or minimum. I just said for maximum and minimum, find the vertex. I didn't say anything about graphing. I put it on a graph to kind of visualize what's happening. Okay, but remember what we talked about the last like few days. If I had a problem like this, well, I'll put numbers in there. Okay, I know that this graph opens up. It looks like that one because the 2 in the front positive. If I had one like this, I know this one opens down, we call it, like the one way over here on the left, because it's like it's a reflection. That 3 is negative. So when the graph opens up, you're going to have a minimum. When the graph opens down, you're going to have a maximum. Like the graph opening down is the one on the left. That means the vertex is at the top. It opens up, the vertex is on the bottom. So you don't have to graph anything on those last three problems. It says tell whether the function has a minimum or maximum value. You should be able to know that and do nothing in the problem. Okay? Like, there's other problems that you're not going to do, but like it has -5 in the front. That means it opens down. It's going to have a maximum. One has has a 2 in the front. That's positive. That means it's going to open up. It's going to have a minimum. There's one that has a 1/5. You're not going to have to do that problem. But 1/5, it's positive. That means the graph opens up. You're going to have a minimum. Okay, I didn't do anything. I just read the problem. Then, when it says find the value, you have to do the -b/2a, and then you have to plug it in. And remember, the value is the y part. So, like up here on the top, we had a 3 as the maximum value, and down here we had -3 as the minimum value. It's just the y part of the vertex. Okay, so you're only going to fully graph a couple of them. The rest of them you're just going to read it, or you're going to find the axis of symmetry in the vertex. Okay, and then it's just plugging in numbers. We practiced that already, so I'm not worried about that part of it. Okay, all right, that's all I got for you today. Have a good day. We'll do some review tomorrow. All right, talk to you later.